So 7.5 is properties of logarithms. And there's several things going on here. In particular, there's 3 properties that we're going to look at that you're going to need to be able to use and go between. So it's going to be kind of important to make sure you get good notes. There's going to be some opportunities for you to take pictures of the screen and or screenshot from your book, and I've put the pages in the presentation so you can choose which one you want to do. Okay? So, first one. On page 1108, if you want to screenshot it. Okay, the first property is product property. And really what it's saying is if you have a logarithm and you happen to have 2 factors being multiplied together inside here, then you can actually separate this into 2 logarithms by addition. Okay, so up here, I mean this example is not a great example because it really should, the problem would have been log base 2 of 30. Like if you get the problem, it would say this. If you wanted to break it up, for example, if you knew what log base 2 of 5 was and log base 2 of 6 was, and sometimes they're going to give you that in the problem, you would want to break log base 2 of 30 up into those separate logarithms. And when we look at an example, you'll see what I mean. Okay. But bottom line is, if you have the log of something and you can break it up into factors, numbers that are being multiplied by each other, you can actually separate one logarithm up into 2 logarithms by addition. Okay? That's what the product property of logarithms is all about. Okay? And you'll have problems like this, and it'll tell you use log base 4 of 2 equals to 1/2 to approximate the value of log base 4 of 32. Now, what our goal is to take 32 and break it up so that you're using 2. Okay? And because this is the product property, we need to figure out a way to multiply 2 by, I don't know, something or several things in order to make it 32. And in fact, in this case, the only thing we have is log base 4 of 2. So how can I multiply 2 by itself a bunch of times to get 32? How many 2's would I need? I need to have 5 2's. So 2 times 2 times 2 times 2 times 2 would give me 32. So I can use this and basically just separate it out like this. So the reason that we can do this is because 32 is just 2 times 2 times 2 times 2 times 2. In reality, I'm taking log base 4 of that. And if I have things being multiplied together, I can separate them into separate logarithms and combine them using addition. Okay, that's what the product property allows us to do. Now, we know what this is. They told us what log base 4 of 2 is. What is it? 0.5. So all I have to do is replace each one of these with 0.5. And I'm going to be able to tell you what the value of log base 4 of 32 is. So when I add those all up, what do I get? 2 points. Okay. That's how the product of property of logarithms is going to work. Now, most of the time they're going to give you 2 different logs. So they might give you log base 4 of 2 and log base 4 of 3. So your problem might be log base 4 of 6, so you want to separate them 2 times 3. And in your homework, you're going to have to kind of problem solve those and figure out, all right, here's the information I'm given. How can I come up with this number with the information given? Since I was only given this 2, log base 4 of 2, I was stuck with the idea that I just had to only use that. And we were able to figure out that 2 times 2 times 2 times 2 equals 32. Okay? Questions on that? Alright. Let's look at the quotient property. This is on page 1109 if you want to screenshot that. Or you can take a picture of the screen. So notice here that when we divide, or we can turn this number into a division problem, I can separate them into two logs using subtraction. So that's how the quotient property works versus the product property. The product property, you can separate them using addition. The quotient property, you can separate them using subtraction. And here's the example they give us. So if I was trying to find log base 2 of 5, 6, they'd have to give us the value log base 2 of 5 and log base 2 of 6, which in your homework they will give you those things, okay? Because you're going to see problems like this. So here's what I'm talking about. So they give us, this is what the directions would look like. Use log base 4 of 3, approximately equal to 0.7925. And just so you know, when we start using our calculator for logarithms, you'll always round to the nearest 10,000th place, 4 places. Log base 4 of 5 equals 1.1610. So what we're going to do is change this problem using the quotient property. So what would that look like after we change this problem? Just raise your hand if you think you know what it is. How would I rewrite this problem as two separate logarithms? Andres? No, not quite. Okay, so I need to use this property here to turn it into two separate logs. So let's not worry about these decimals right now. Let's just use the quotient property to separate it into two logarithms. So you want to try that again? Nope. Yeah.
I'm not sure if it's nice to say, but log base 4, 5
Uh-huh.
minus log base 4, 3.
Correct. Okay. So all we're going to do is separate it into two logs using subtraction when you have division inside there. That's all you really have to do. Okay. And now they've given us what log base 4 of 5 is. And they've given us what log base 4 of 3 is. So now we just substitute those values in and do the subtraction. Are there questions about that? I'm not quite done. I got one more step. But questions about how I came up with this? How many understand where that came from? Raise your hand. Okay, good. So there's my final answer. 0.3685. That's how you would use the quotient property. Okay. Next, the power property. And this is on page 1111. Here's what this one's saying. If you have a logarithm and you have an exponent inside that logarithm, you can take that little power and throw it out in front and get rid of it, basically. Okay? So I can take the p that the power is and put it out in front of the log, and it'll just be like the power went away, almost. It's still there in the front, but it's not inside there anymore. And you see our example here, log base 2 of 6 to the 5th. The 5, the little power comes out in front and just gets multiplied by the logarithm now. Okay, that's the power property. So when you see a logarithm with a power inside, like this, you can take that power and just swing it out in front. Okay? And then it goes away on the inside. So the types of problems you're going to see are going to look like this. So they give you this first part. This is going to be given. And now what you have to do is then figure out, okay, how can I write the second one using log base 3 of 7? Well, you should see a relationship here, right? What's the relationship between 7 and 49? Okay, 7 is the square root of 49, or I could rewrite 49 as 7 squared. Okay. So if I rewrote 49 as 7 squared, now I can use the power property because I can rewrite this as just log base 3 of 7. Where does this 2 have to go? Goes in front. So in reality, what I'm doing is I'm taking log base 3 of 7 times 2. And we already know what log base 3 of 7 is. They gave us that. So it'll kind of look like this. 2 times 1.7712, which of course is 3.5424. Now, these properties are going to play a bigger role when we're solving equations. Not so much when it's just numbers like this, because the reality is you have the technology to do most of the ones with just numbers on your calculator. And eventually I'll show you how to do that. We're just not there yet. But for the most part, we're going to use these properties to solve equations. Okay? So that's what we're going to turn to next. Any questions so far? And actually, we're going to do one more before we do this, because I want to look at one more problem. And this one again. We already solved this one. We know it's 2.5. Okay, but I want to show you that there was a different way that we could have approached it. When we originally did this problem, we talked about 2 times 2 times 2 times 2 times 2. Well, how could I rewrite 32 as a power? 2 to the 5th. So let's just make sure that it still equals 2.5. If I would have rewritten this as 2 to the 5th, then the 5 comes out in front, and we already know log base 4 of 2 is 0.5. 5 times 0.5 is 2.5. So sometimes you're going to have the choice of which property you want to use. And depending on your preference, that will dictate which direction you want to go. But know that sometimes there's more than one path to get to the right answer, and whatever path you choose is going to be fine. Okay? Alright, let's look at some equations. So here are the types of equations that we're going to be looking at today. Alright. And at this point, what we're trying to do is turn them into the equations that you were solving yesterday. And they aren't there yet. Because what we want to get it to be log equals a log. One log on each side with the same base. Because if we have that, then we can solve like we solved those equations yesterday in 7.4. So we need to get that done. Okay? We need to turn this into a problem so that it looks like this. Let's focus on this left-hand side. How could I turn this into just one log? Like the problem is this 2 out here. What am I supposed to do with it? Where can it go? To the x, how? Squared. So if we took that power property and did it in reverse, we could actually just make that log base 7 of x squared. So now it's one log on that side, and I'm good on that side. Okay? How can I use one of my properties to simplify this right-hand side? This addition sign should be your clue as to which property you're going to use. Jenna, which property are we going to use? Nope. Yeah, Kenzie? The product property. When I separate into two different logs with an addition sign, if I want to combine them into one log, I have to multiply. And then I can make it one log. So that's just using the product property backwards. Okay, if this would have been subtraction instead of addition, I would have used the quotient property. Okay, so now I've got it to a place where it's one log equals one log. And so I can basically drop the logs. Okay? So my equation that I'm solving is x squared equals 81. So what's x?
9.
Yeah? Plus or minus 9. Whenever you square root both sides, you have to plus or minus. Two solutions should be plus or minus 9, but now we have to check.
You have to check for both plus and minus?
Yes. And no. Since I only have one x, what type of number here will give me a problem? A negative. Okay? This can't be a negative number. So I can check right now if I plug negative 9 in here, we have a problem. So I actually have to throw negative 9 out. So had you solved this equation incorrectly and just got positive 9, you would have got lucky. Because we do have to throw the negative 9 out because of this. Okay? So my solution is just x equals 9. Okay? Questions on that? Alright. You do this one. Here's what you should have had. Okay, so I combine this together using the quotient rule since this is subtraction, so I can just take 48 and n and turn it into one quotient. Since 48 came first, you have to do 48 over n. I didn't do anything over here. Basically, you get rid of the logs. 48 over n equals 6. What number divided by 48 divided by what number equals 6? 8. Okay. How many had that? Alright. So you've got lots of different properties you're dealing with here. You got product property, you got quotient property, and you've got power property. And you have to know how to use all three, and sometimes you're going to combine them together to solve the types of problems that you're going to be looking at today, okay? Make sure when you're solving equations that you check your answers. That's it.